Good morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today, we are going to all discuss about a free space management system in operating system. A free space management is a backbone of how an environmental system handles a disk storage. Imagine if your disk as a giant warehouse where you store file. If you don't know which cells are empty or how to use them efficiently, you will waste space and slow down your operation. Whereas the free space management ensures the OS can quickly find and allot unused disk space for a new file system, which directly affects how fast your system runs and how stable it is. A poor management can lead to delay in an operations or even crashes, impacting the user experience. For example, when you save the document, the operating system needs to find free space on the disk to store it. This is what the free space management system is all about. Understanding the free space is where to understand a free space, let breaks it down. A disk is like a notebook divided into pages where each page is fixed space block, typically for 4 KB. These blocks are the smallest unit where the operating system uses to store your data. The free space is simply those blocks that are empty or unloaded, waiting to hold a new files or a data. For example, if you are saving a photo, the OS looks for these free blocks to store it. The goal is to use these blocks efficiently to avoid a waste space and keep the system running smoothly. Inefficient allocation can lead to fragmentation, where a free space is scattered in a small, unusable chunk, slow down your file access. Think about it trying to get into a large book into a shelf with one triggering tiny gap. It's very tough, where effective allocation ensures a minimal fragmentation, optimizing the performance, and it will lead to further tracking of the data structure for tracking of free spaces is where it keep track which blocks are free and the OS use a specific data structure. The first is to bitmap, a simple and efficient method. Imagine a long strip of bits where each bit corresponds to the disk block. A 0 means that the block is free and the 1 means it is allotted with 1 TB by disk with 4 KB blocks. The bit maps are greatly for quickly finding contiguous free block, which is useful for a large files. The second method is a linked list, where each free block or scatter finding enough space for a files can slow. The next comes the allocation strategies. Once operating system knows which block are free, it needs strategies to allot them to the file, and there are three main strategies: first fit, best fit, and worst fit. The first fit is the simplest. It picks the first block that's big enough for the file. It's fast but can lead to fragmentation because it does not consider the size of the remaining free space. Best fit search for the smallest block that can hold a file, minimizing the waste space and the fragmentation. However, it requires a searching of the entire list of free block, which can be slower. The worst fit takes the largest space of the block, scoping to leave a bigger chunk for a space or for the future use. It's rarely unused because it is very efficient. Choosing the right strategies depending upon the system needs, we can move to the contiguous allocation. The contiguous allocation is where the file is stored in the continuous chunk of block like a single chapter in a book. This is simply because the OS only needs to track the starting block and length of the block. It is efficient for reading because all data are together. However, it has a big down and and it has a small chunk of impossible storing of 5 kbs 5 kbs of data. Whereas a non-contiguous allocation is where the non-contiguous allocations allows a file block scattered across a disk like a page of a book spreading out to the different memory allocations. This is more flexible because the OS can use a free blocks, reducing external fragmentation. The internal and external fragmentation is where the fragmentation is a major challenge in free space management. The internal fragmentation happens when the block is only partially used. For example, the 4 KB of block is allotted for 1 KB of file, whereas the external fragmentation requires when free space is scattered in a small chunk across a disk. Even with enough total space, you might not have a single large enough block for a single file. Defragmentation technique is where to comport your fragmentation, we use defragmentation technique, that is compacting physically moves allotted block together to create a larger free space. And last is all about the practical consideration. Choosing the right free space strategies is critical. For example, bitmaps are greater for a speed but might not suit every file system, while linked list are simpler but smaller in fragmented. Hence, I conclude this with stating free space management is a cornerstone of operating system performance by efficiently tracking and allotting a free disk space, ensuring a faster operation and system sustainability. Thank you.